All right, day 2 of complex numbers. Today we're going to talk about multiplying complex numbers or finding the product of complex numbers. And this is very similar to multiplying two binomials using the FOIL method or the box method. So in our example, if we have a plus bi times c plus di, we multiply a times c, we multiply a times d, we multiply bi times c, and bi times di. And in this case, the I times the I gives us an I squared. And if you remember from the last set of notes, I squared is really equal to -1. So we can rewrite this expression as A times C plus A times D times I plus C times B times I. And then instead of plus A times D times I squared, we can write that as minus B times D. And then combining our like terms, the AC and the BD do not have an I, so they can be grouped together. And the AD and CB do have an I, so they can be grouped together, leaving us with our final answer. Let's take a look at some specific examples. 5 plus 3i times 2 plus 7i. If we think about this with the FOIL method, we would take 5 times 2 plus 5 times 7i plus 3i times 2 plus 3i times 7i. Simplifying this a little bit, we have 10 plus 35i plus 6i plus 21i squared. But again, that I squared, that's like a -1. So this is the same as 10 plus 35i plus 6i minus 21. My 6i didn't turn out so well. So combining my like terms, the 10 minus 21 would be like terms. And 35 plus 6 would be like terms, and they have the I with it. Subtracting, I get -11 plus 41i. If you prefer the box method, we can do that as well. We have 4 times 3. 3 times minus 5i. 2i times 4. And 2i times minus 5i. So we would have 12 minus 15i plus 8i minus 10i squared. And again, the I squared is -1, so instead of minus 10i squared, I can write that as plus 10. So I have 12 plus 10 plus negative 15 plus 8i, which is 22 minus 7i. Again, very similar to multiplying binomials using FOIL or the box method. Both methods work equally well. You'll have a chance on your homework to show that. Have a wonderful day.